Assalamualaikum and hi, my name is Muhammad Hari Lokman bin Muhammad Khairi and my meeting number is CF220224. So for now, I will present to you guys about introduction of our project. Before I start, I hope you guys clear with my explanation. So for not wasting time, let's continue, okay? Okay, the first one is introduction. Hydrology is the study of water resources in the context of civil engineering. The definition of the hydrological cycle is the movement of water by precipitation from all freshwater bodies, seas, and land from the Earth's surface to the sky and back again. In order to understand the amount and quality of water as goes through the cycle, hydrologists look at basic transport process such as rainfall, infiltration, stream flow, groundwater readings, and other elements. Excessive rain will cause flooding in some areas with dense population and poor drainage system. As an engineer, we must take the first step to prevent floods. There are several methods that can be used, among them identifying in advance the areas that often flood. Then, for the location, collect rainfall and water level data. This can research how frequently it rains in the area and notify the populace in advance. So that's all from my introduction. And next, we will continue with problem statement. Stay tuned. Okay, for the problem statement, we use the rainfall and water level data from three stations in Route District to determine the mean area rainfall of the purpose catchment area, peak flow of purpose of catchment location, discharge of the river at the maximum data level and unit hydrograph. The station that's involved are Sungai Lipis at Kampung Pos, Sungai Lipis at Batu Malim, and Sungai Dong di Kampung Perwas. However, determining which areas flood frequently has been used to choose the site for rainfall. We have selected the Lipis district in Pahang due to its sensitive flooding, as reported by reputable news and WhatsApp sites as the Jabatan Pengelolaan dan Saliran JPS and the Jabatan Meteorologi Malaysia Met Malaysia. Okay, that's all from our problem statement, and next we will continue with the last part from me, which is objective. Thank you. Okay, for our objective, we conclude that we got three objectives from the problem statement because these two things are related. So the first one is to collect and interpret daily rainfall data using Department of Irrigation and Drainage website at the public info Banjir. Next, to determine the current water level data from the specific station. And lastly, is to compare the results obtained from the proposed topographic map catchment area for each station. So that's all from me. I will pass this presentation to my friend. Thank you.
For the methodology part, how do we find the mean area rainfall? Firstly, we are going to use arithmetic mean method, which is P equal to total Pi over N. Secondly, we are going to use Thiessen polygon method, which is total polygon area for each station times with precipitation depth divided by total polygon area. Lastly, we are going to use isohydrate method, which is P equal to total sub-area between two isot lines times with average precipitation between two isot heights divided by total area. For the hydrograph and hydrograph, the hydrograph and hydrograph table for each station was obtained from the website of the Department of Irrigation and Drainage. The hydrograph displays the value of rainfall data while the hydrograph displays the water level data for selected stations in Pahang for a year with similar 5 months and 5 days. A peak flow is the maximum rate of discharge during the runoff caused by a storm. The analysis of observed discharge data and runoff hydrographs can be used to compile information about peak flows and associated volume of runoff during previous floods. The formula of Q equal to C times I times A divided by 360, while Q equal to peak flow in meter cube per second, C equal to runoff coefficient, I equal to rainfall intensity, millimeter over hours, A equal to drainage area.
Salam sejahtera. Now I will present my part, which is data presentation in this hydrology project. So for this project, we already prepared the two types of the data. One is the rainfall, another is water level. And the rainfall station we selected as at Batu Malim, JPS, Stok, Laut, and the Kampong Perluas. And the water level selected, we select at the river Sungai Lipis at Batu Malim. So in this slide, we can see clearly there are the two types of the graph. Photograph is recorded the water level at Sungai Lipis di Batu Malim, and the photograph is record the rainfall at the three station we selected in Raup district at the Negeri Pahang. For this slide, we also can see clearly in August and September. We can see clearly the water level is for the Sungai Lipis at Batu Malim and the rainfall data station at 3 stations. So we can see clearly we selected the 5 highest data, rainfall data, and the water level in August and September 2023. So that's all for the data presentations. For this slide, we also can see clearly in August and September. We can see clearly the water level is for the Sungai Lipis at Batu Malim and the rainfall data station at 3 stations. So we can see clearly we selected the 5 highest data, rainfall data, and the water level in August and September 2023. So that's all for the data presentations.
Hi, my name is Hasil Azim Adinan. My matric number is CF220075. So we move to the chapter 4, which is analysis and result for arithmetic mean method. So for average precipitation depth equation, we need a total rainfall for each station that we have. So for January, we got 142 millimeter depth. For February, we got 104.5 millimeter depth. For March, we got 89.83 millimeter depth. For April, we got 46.17 millimeter depth, and for May, we got 58.33 millimeter depth. So for the next part for chapter 4 is decent polygon method. We sketch the polygon that cover the 3 station in Raup. So the total area of catchment we got is 2604.7 kilometer. So for area from Kampung Perwas is 898.10 kilometers square, and for Batu Malim 1008.52 kilometers square, and the last one for JPS Torau area is 698.10 kilometers square. So for January, the total area will be divided by the area multiply with precipitation. So we got for January we got the 144.18 millimeter, and for the February we got the 101.67 millimeter. For March we got 19.50 millimeter. For April we got 50.91 millimeter, and for May we got the 40.20 millimeter. So we go to the next part of chapter 4 is isohedral method. So we draw or sketch the isohedral method just like the decent polygon to cover 3 stations in Raup. And we got the total area for isohedral method is 2,1918.05 kilometer square. So for each one, we got 5 interval for this isohedral method. After we got area for each interval in isohedral method, we multiply with average precipitation, and the total of it we divided by the total area, and we got average precipitation depth. So we got 16.51 millimeter depth. So we move to the calculation for slope. We got this elevation from the Google Earth Pro. So for the calculation, we need a highest and the lowest elevation, and will be divided by the length of it. So for the slope 1, we got 19.13, and the slope 2 we got 5.06, and slope 3 we get 9.13. After that, we go to the calculation for discharge. So we use the same elevation of the slope for this cross section, and we put into the discharge equation. So for cross section 1, we got the 251.5537 meters squared per second. And the cross section 2, we got 649,359.38 millimeter cube per second. For the cross section 3, we got 719,202.87 meter cube per second.
Hi, my name is Muhammad Amirul Aiman bin Abdul Halim. Let me continue for the hydrograph. In hydrograph, we only pick one station and take 3 month height hertz data between 5 months. This is formula that we use in hydrograph. We continue for the calculation in next slide. For the next this is calculation for hydrograph. As you can see, the 3 month height hertz data, which is March, April and May. The point is, we use the formula that I showed previously and use in this calculation, which to calculate the aerial anti-total flow, and this is what I get it. In this slide, shows the data hydrograph using straight line method in March, April and May. Total flow we get from our calculation in previous slide. From this method, we can get the base flow and direct flow from day 1 until day 5. For the unit hydrograph, this is the formula that we need to use to determine the UH ordinate. As you can see in this slide, shows the formula to determine UH ordinate, direct flow, total direct runoff volume and equivalent runoff depth. For the calculation, we go to the next slide. On this slide, we can get UH ordinate from the previous formula. Also, we get the graph, which is UH ordinate Vs time. We calculate in March, April and May. As you can see, that is the data that we calculate in this UH ordinate. The next is in discussion. In discussion, there are 3 rainfall data, which is JPS Torau, Batu Malim and Kampung Perwas as the station with similar date to collect the daily rainfall using hydrograph. The data have been taken in 5 days and 5 months in a year. The mean area precipitation that we have calculate using 3 different methods, which is arithmetic mean method, Tyson polygon method and associate method. Furthermore, we calculate the hydrograph and direct flow using straight line method. We construct the graph using water level data from Sungai Lipis at Batu Malim, and the value that we obtain are used to calculate unit hydrograph. However, the month that we choose to construct only 3 months, which is March, April and May, because of this is data have the highest water level among the other month. Finally, in conclusion, we know that the different part of the world receive various quantities of rainfall and learn how to recognize between precipitation and runoff by finishing this assignment. Furthermore, we can establish that as precipitation increase, so does runoff until the peak of release. All rainfall and water statistic we are obtained from the public info banjir site and examine it. In order to control the water level, the hydrological framework has to apply in this project. Thank you so much.